So I saw this guy last week. He was trying to use a generic one-size-fits-all checklist on a reciprocating piston compressor, a rotary screw, and a high-speed centrifugal unit. I literally told him, look, this is like trying to service an old muscle car and a commercial passenger jet with the exact same socket set. It is just madness.
Oh, absolutely. I mean, they are completely different beasts. Welcome to the Big Dog Podcast, everyone. I am Lisa Saunders, and with me is Jason Reed. And Jason, that car and jet analogy is spot on. Because today we are asking the real question. When you look at the actual physics of these machines, which compressor design actually wins the long-term maintenance battle? Like, who makes your life easiest?
Well, let us start with the old robust veteran, the reciprocating piston compressor. These things are basically positive displacement tanks. They squeeze the air by physically driving a piston up and down inside a cylinder. But because of that design, you have parts physically touching. Piston rings, valves, packing, oil seals, they are all rubbing together, which means you have massive amounts of friction, high vibration, and let us be honest, they run incredibly hot.
Right? And because they run so hot, they demand constant, hands-on attention. We are talking about changing the oil way more frequently, like every 500 to 1,000 hours of operation. And changing those valves, that is not some 10 or 15-minute job. It takes real mechanical skill. If you try to run a recip to failure, you are looking at a catastrophic blowout, oil getting injected right into your airlines, and massive downtime.
Exactly. Run to failure is just not an option with a piston unit. Now compare that to a modern rotary screw compressor, the workhorse. Instead of a piston slapping up and down, you have two interlocking helical rotors spinning continuously. And here is the magic. In an oil-flooded screw, those rotors never actually touch each other. They are buffered by a micro-thin, pressurized film of oil.
Wait, let me make sure I have this straight. So, the oil is not just there to keep things slick. It is actually acting as a physical seal to trap the air, a coolant to pull the heat away, and a shock absorber all at once? So you are completely eliminating that metal-on-metal friction?
You nailed it. The oil is the absolute lifeblood of the rotary screw. Because that oil film prevents wear, the rotors themselves can last for years and years if you maintain the oil system. But, and this is a huge but, because the oil does so much heavy lifting, you have to keep that entire oil circulation system pristine. The air oil separator, the scavenger line, the coolers, they all have to be serviced. If you neglect them, the whole system breaks down.
And the first line of defense there is the inlet air filter. People treat it like a cheap afterthought, but if that filter gets clogged, it restricts the incoming air that forces the compressor to increase its compression ratio, which spikes the discharge temperature. Suddenly, your oil is running too hot, it degrades, the air oil separator gets ruined, and you get a massive cascade failure across the entire machine. It gets really expensive really fast.
It does. But the beauty of the rotary screw is that, unlike a piston unit or a centrifugal, standard maintenance is simple. You do not have to open the internal casing or get into the guts of the machine. If you can service a car, you can do the routine maintenance on a rotary screw. It keeps labor costs low and does not require highly specialized technicians. Now let us step up to the high-performance specialist, the centrifugal compressor. This is not positive displacement anymore. It is dynamic compression. These are big units, usually above 400 horsepower. They use precision-engineered impellers spinning at blistering speeds to accelerate the air molecules, and then a static diffuser converts that velocity into pressure.
Okay, so if we look at the physics, there are almost no touching parts in the compression chamber of a centrifugal. So on paper, it sounds like the absolute ultimate champion of low maintenance, right? Just change the air and oil filters, clean the coolers, and you are done.
But there is a major catch. It is a classic complexity paradox. Yes, routine maintenance is simple, but because those impellers are five-axis machined to incredible tolerances and spin at extreme speeds, they are incredibly sensitive. If you have a surge condition where the system flow drops too low, the compressor can violently surge, which can destroy the impellers in seconds. They rely on complex surge anticipation controls and sophisticated vibration monitoring to stay safe.
So if something actually goes wrong, or when you need advanced service, your general maintenance team cannot just roll up their sleeves and fix it. You have to fly in specialized, factory-trained technicians. So the labor cost and the specialized expertise required are on a completely different level.
Exactly. You are paying for high-end expertise.
So let us line them up. Who actually wins the maintenance crown? If you are a plant manager looking at reliability, ease of service, and predictable costs, who takes it?
For the vast majority of facilities, the rotary screw is the clear, undisputed winner. It gives you the perfect balance. You do not have the high-wear, high-touch manual labor of a reciprocating piston unit, and you do not need the highly specialized, ultra-expensive engineering support of a centrifugal. It is reliable, the service intervals are long, and your local mechanic can keep it running beautifully.
That makes total sense. It really comes down to aligning your maintenance strategy with the physical DNA of the machine. You cannot treat compressed air as a black box. If you know what is happening inside, you can prevent the failures before they start. Well, that is our take on it. Thanks for listening to the Big Dog Podcast.
Keep those filters clean, everyone. Talk to you next time.